Hello everyone, my name is Matthew Cilk, and we're going to continue talking about the Cilk runtime, specifically work stealing. So, if you don't remember how the Cilk runtime worked, there are a bunch of threads called workers. These break their kernel stacks into a bunch of smaller chunks and store the smaller chunks in a spawn deck, as pictured. The reason Cilk performs so well is that other workers can steal and resume execution of the top of another worker's spawn deck. We're going to be focusing on that point. Now, at first glance, even if it sounds fairly conceptually simple, implementing this could be quite tedious. And indeed, but if you look at it, it's two separate parts. Stealing and resuming. Now, resuming is actually called. Every runtime does it a bit differently, so we're going to postpone talking about that and instead focus on stealing. Now, take 10 seconds to think about how you would implement work stealing. Actually, you're not going to get 10 seconds, but if you did, you probably would have come up with ideas like this. Maybe a really lazy approach, where you just change the frame's owner. Obviously, that's not going to be enough. The worker has to have some idea of what frames it owns. However, it's probably a good start. You may come up with a more complicated approach using interrupts so that the victim can transfer frames to the thief. However, interrupts are relatively slow and inconsistent, so we're going to throw that idea out right away. A more refined, distributed version of that might involve message passing. However, if you don't like that, you may instead do a locking approach with a bunch of locks, because that always works out. Obviously, we need to take a step back before we can answer this. Let's first start with which worker should manage the steal, victim, or thief. To answer that, let's consult the work first principle. If you haven't seen this, it's that you should move overheads out of the work and onto the critical path. However, it's not always immediately clear what that means. Sure, you can figure it out if you sit down to think about it, but if you're just doing a 5-minute presentation, you probably need a simpler version that is more in tune with your intuitive idea of work. That gets us this very simple principle. Don't burden the guy who's already doing work. In other words, have the thief do it. Now, with that out of the way, we still need a way for the thief and victim to share information. We've already ruled out a weird interrupt system, and the message passing refinement probably runs the file of work first. It's going to need some polling on the behalf of the worker, the victim. Now, software is designed for shared memory machines, so we can probably get away with atomic read-write registers. So the next natural question is, how many of these variables do you need? Obviously, you're going to need a tail variable for the end of the spawn deck. You're also going to need a head variable for the actual start of the deck. Now, if you're thinking, wait, isn't the start always the same? The first index in the spawn deck? Then no, it isn't. When you steer at the top of the deck, you're effectively making that index unusable, so you need these two variables. Sometimes we also add a third variable for executing or exception. This is for, well, exception handling. We're going to ignore that because we are quite easy and think we can cover it in 2 minutes. However, these three variables form the name of the protocol that's actually used, the THE protocol. So ultimately what it does is it increments and decrements the tail variable based on whether it's pushing or popping a frame. And the sheaf similarly increments the head variable as it steals from the spawn deck to make sure that these don't run into any concurrency issues. We use a lock, and that lock is invoked by the worker if it finds the head beyond the tail. It's always invoked by the thief to make sure someone else doesn't steal. It'll take you about a minute to convince yourself this is correct. Proving is a bit harder, but it's still fairly simple. If you want more detail on it, I recommend this paper on Cilk 5 implementation. It's a very good read. I hope you found this interesting. Thank you.